We're going to identify key functional groups and drugs, ingredients, and other molecules. Let's start off with vanillin, which you might guess gives us vanilla flavor. We're going to start with a simple one here, which is a hydroxyl group. You might be tempted to call this an alcohol group, and that's not completely, totally 100% wrong, but we'll talk about the difference later. But as the name implies, hydroxyl means hydrogen and oxygen connected to some stuff. Then we have something called a carbonyl. So I'm going to highlight the carbonyl, and then we can talk about what carbonyl is. A carbonyl is a carbon that is double bonded to an oxygen. You'll find it in a lot of functional groups. It's important to identify carbonyls and then ask yourself what's on the other side. So here it doesn't look like we have anything right here, but we know that there is a hidden hydrogen, which means this is an aldehyde. When you have a carbonyl, and that carbonyl carbon, which is this thing right here, when that carbonyl carbon is attached to some carbon stuff on one side of the carbonyl carbon and then a hydrogen as like a terminal thing, we're going to call that an aldehyde. What does aldehyde mean? Or what does it end with? Aldehyde ends with "hyde" for hydrogen, and aldehydes literally end with hydrogen. You know hydrogen can have more than one bond, so it kind of like is a stopper. Aldehyde ends in hydrogen, and so does an aldehyde. And then over here, we have something called an ether. Now, people get ethers mixed up with other things. We'll talk about that in a bit. But here's how I remember that this is called an ether. Take a look at this oxygen. It's connected to a carbon on one side and a carbon on the other side. And neither of those carbons are carbonyls. So you could think of it this way. The generic formula for an ether is ROR, where R is just carbon stuff. So think of it this way. Either or. That's how I remembered it. Either or, you can go this way, or you can go this way, either this way or this way. So if you look at the generic formula for an ether, it spells or in both directions. How cool is that? Either or, this way or this way. And then of course we do have this arene, which is just an aromatic ring here. But we're not going to focus on those too much because most of the time, a lot of the time, things are coming off of those. So here we have a hydroxyl, an ether, and an aldehyde. And I will put the generic formula for an aldehyde. It is some R stuff. Remember that you do have a carbonyl, so carbon double bonded to oxygen, and it's going to end cap with a hydrogen. Now let's do the next molecule where we get to talk about ethers versus esters. We're going to see that this molecule is going to have an ester. Let's identify the carbonyl first. This is our carbonyl, C double bonded to an O. So this is a particular functional group called not an ether, it's called an ester. Now it's pretty common for people to get these mixed up because they're both 5-letter E names, but notice how an ester does have an oxygen, so let's identify this oxygen, just like an ether does. And this oxygen is connected to a carbon on one side and a carbon on the other side, just like an ether is. However, notice how on an ester, one of those carbons is a carbonyl carbon, and that's what makes it special. So this is the generic formula for an ester. R stuff, carbonyl carbon with an oxygen that's not double bonded to the carbon, and then some different R stuff. So make sure you know the difference between an ether and an ester. Generically, ROR, that's going to be an ether. Remember, either or. But an ester is going to be R carbonyl OR. So that's the difference. And of course, we already know that we have a hydroxyl here. So I'm just going to circle hydroxyl and write it out just so you're used to seeing it. Here we have a molecule. It's a pretty large molecule. Let's look at the left side of this molecule, and I'm going to draw it out in another way it could have appeared. They could have written it out just like this. I'm just drawing this section of it. Now, why could they have just written it out like this? You don't have to show the CH3 here. You could have just left it as a line, which we know would be a carbon with 3 hidden hydrogens. But the reason that it's helpful to recognize it in this format too is because if you're asked to identify a functional group and you don't recognize that this is also an ether, then that might be a problem. So this is an ether, and you can verify because it's some carbon stuff with an oxygen in the middle and some other carbon stuff. And neither of those carbon stuffs are carbonyls. We also have an ether here. Why is that? Because we have carbon, oxygen, carbon. Neither of those carbon are carbonyls. So I'm going to write out ether just so you're not looking back at it like, what is that? Here we have a hydroxyl. But specifically, notice that this carbon here is sp3 hybridized. So you can call this hydroxyl an alcohol. Let's take a quick aside to see, are hydroxyls alcohols? Well, I will tell you that alcohols have hydroxyls, the best way to name them, generally speaking, is that an alcohol is going to be an OH group connected to an sp3 hybridized carbon. If that hydroxyl, that OH group, is connected to an sp2 hybridized carbon, and that sp2 hybridized carbon is part of a ring, particularly a 6-membered ring like this, it would be a phenol for the phenyl, or the phenol and the OL. Now notice how all these end in OL, which gives you a clue that there's an OH on it. Now this is a double bond, which you know is an alkene. So remember, alkenes are double bonds. That's where the ene comes from in enol. And the ol in enol comes from the fact that there is, of course, an OH or a hydroxyl group. And this carbon is also sp2 hybridized. So if you're not sure, just default to calling it a hydroxyl unless you can tell what else is on, and then you can pick the better, more specific names for it. And what is this? This is a nitrogen. First time you've seen a nitrogen today. So a nitrogen, when it's not connected to carbonyl carbons, is just called an amine. So this nitrogen is connected to 2 carbons, carbon over here, carbon over here. So this is an amine. It's not an amide, which we'll talk about later, because this nitrogen does not have a carbonyl touching it, a carbonyl carbon touching it. But notice how this nitrogen does have 2 carbons touching it, which means it's a secondary amine. If there were just 1 carbon, it'd be considered a primary amine. If it had 3 carbons touching it, it would be considered a tertiary amine. We'll talk about those in a bit. But just identify that this is an amine, and if you can count the number of carbons it's touching, then you can determine if it's primary, secondary, or tertiary. The generic formula for an amine is going to be some R stuff, and this particular amine is going to be R. We have nitrogen, and this one does have a hydrogen on it, so I guess if you want to be more specific, it's going to be some other R stuff. So we can go prime and double prime. But for this case, one of those R's is just hydrogen. So we're going to get rid of that. We're going to put H, and you can see how it does fit. You can replace up to 2 R's with an H. So I could also, also get rid of this one, make that an H by just putting this as H2. Now, if you get rid of all the R's, so if I do this, suddenly it's not even a functional group. It's just a free-floating ammonia. But let's back it up, and I can give you a generic amine formula like this. This is a large molecule. We can see that it ends in OL, it's cholesterol. So we're only going to focus on one main functional group here, and that's this. We have our hydroxyl. And are you allowed to call this an alcohol? Look at the carbon it's connected to. This is an sp3 hybridized carbon. So yes, you can call it a hydroxyl. Or I should say you can call it an alcohol, but we can just label it as a hydroxyl for now. This is a really cool molecule because it has carbonyls here, here, and here. But the main thing I want you to understand is that these 3 carbonyls are parts of 3 different functional groups. So let's start with the one that we don't know, and that's this right here. This is called a carboxylic acid. So carboxylic acid. You'll learn more about why it's called an acid, but effectively it's because this hydrogen here is ionizable. It can leave and you'll be left with, well, not hydrogen anymore. So when hydrogen leaves, that proton is donated, that makes it an acid. So carboxylic acid has a generic formula of R stuff with a carbonyl carbon and an OH on the end. It's similar looking to an aldehyde, and it's similar looking to a ketone, and we have both of those on this structure as well. So this carbonyl on the upper left, notice how we have what looks like nothing, but remember there is an invisible hydrogen here, so I'm going to draw that in. At this point, we do already know that this is an aldehyde. It ends in hydrogen, just like the word aldehyde ends in hydrogen as well. And as a reminder, the generic formula for an aldehyde is R with a carbonyl carbon and double bonded to an oxygen, and then we have that terminal hydrogen there. It's different from, but looks a little similar to, a ketone, which is this. I want you to think about what makes an aldehyde different from a ketone. A ketone, notice that the carbonyl carbon is connected to 2 carbons. One methyl group on the one side, and then the other stuff on the other side. So a ketone is also pretty well, it doesn't have to be terminal, but a ketone is going to have 2 carbons on either side of the carbonyl carbon. So the generic formula for a ketone is R, C double bonded O, that's our carbonyl, and then a different R group over there. Of course, we have our hydroxyl. We don't have to label that, but I'm just going to put it here. And then just as a reminder, we have some double bonds, and those are called alkenes. We'll end this section with this molecule. We have nitrogen coming back again, but these are not amines. These are other nitrogen-containing functional groups. So here we have nitrogen with 2 oxygens on it. So generically it's RNO2. Pretty simple. This is just a nitro group. And that's going to become important when you talk about electron withdrawing and electron donating groups, when you talk about like reaction mechanisms and stuff. And then over here, we have a carbon stuff connected to a carbon that is triple bonded to a nitrogen. So we're going to call that a nitrile group. And the key about a nitrile group is that it's going to be triple bonded. The nitrogen is triple bonded to a carbon. So those are some of the key functional groups. Part 2 will have some more, and we'll keep practicing with more molecules.